My name is Frans Roelofsen and I welcome all of you at the iMOD webinar with the title Create Your First iMOD Groundwater Flow Model. In this first iMOD webinar we will create a MODFLOW groundwater flow model step by step, and it includes basics like data viewing and editing in 2D and 3D. This webinar will be based on tutorial 4 of the iMOD user manual. And for this webinar, no experience in using iMOD is required. So, as I said before, my name is Frans Roelofsen. I am an iMOD trainer and I'm the speaker of this first webinar. And together with me there is a panel of colleagues who are available to answer your questions during this webinar. I will tell you something more about it later. And my colleagues are Peter Vermeulen, he is an iMOD, one of the iMOD code architects, Joachim Hunnik, one of the iMOD experts, and Benny Minema is the product manager of iMOD. You have the possibility for interaction during this webinar. I think your screen looks somewhat similar like the one on the PowerPoint, and on the right side here you can ask your questions to the panel and they will answer you also in text. Let me first introduce the program of this webinar to you. We have a live webinar of about 45 minutes and well, together I'll show you how to get and how to install iMOD, how to start iMOD. I give a general introduction on the use of iMOD, but most important of all, we're going to create our own groundwater model. And after the live webinar, we have a live chat session. It depends on the questions we receive from you, but maybe it will take 1 hour, and you have the possibility to ask some questions, and some of them can be live answered in the webinar. Well, let's start. And we start with how to get and to install iMOD. And therefore I go to my browser and I show you an important web page. If you go to ossdeltares.nl, this is the location where Deltares shows all their tools, and one of the tools developed is iMOD. If you just click on the icon, you'll enter the home page of iMOD, and well, take some time afterwards to read it, but most important for you now are some elements. For instance, on the download menu I'll show you how to get the Deltares executables, and if you have questions in the future I will recommend you the iMOD forum. Here you can ask your questions and other users can answer the questions you have. But first of all, let's go to the download page. I click on download executables, and well, you can see a lot of things you can download. For instance, the source code, the complete source code, because it is open source. But for this occasion I only show you how to get the iMOD executable. If you click on the link before, you see this request form. Just fill it in and you will receive a link to all data files needed to install iMOD. I'm not going to install iMOD in this webinar, but join me to a location where I did it before and I can show you what files are placed on your computer when you've installed it. And I think you don't need administrator rights to do the installation. After installation, these files will show up. I want to show you some important files. For instance, the manual of iMOD. I just open it and you can see it's a manual of almost more than 600 pages, and actually it tells you all about all the things you can find in iMOD and all questions. Most questions can be answered by clicking on this, by reading this manual. Another important file is the iMOD executable. After clicking on this executable, the iMOD Graphical User Interface will start. You will see it in a minute. And another important file is the iMODFLOW executable. So be aware that iMOD and iMODFLOW are separate executables. So later on we are going to run MODFLOW, and iMOD refers to this file. In this webinar we're going to do tutorial 4, and in this directory you find actually all the tutorials. At this moment we have 7. I think this is the most important part for now, so let's return to the PowerPoint. iMOD getting started. So let's go to iMOD. Here I did some preparations, and you recognize here the iMOD executable. After clicking on it, this window appears the first time because it says something about the user agreement, about license. Please read it here or in the manual, and if you agree, you can click yes and accept, and then iMOD will start. In your case there's no project there, so please create a new one. In my case I did some preparation, so I start, and then this window appears. This is actually, if you're familiar with GIS or other iMOD tools, MODFLOW tools, then you can recognize this. This is some GIS window with X and Y coordinates, and there all the files imported in iMOD can be shown. You see already the iMOD manager. That's actually one of the most important windows. You can find it by going to the View menu and click on iMOD Manager, or just use this shortcut. And there you can see all type of files that are in iMOD. Let's just show one. I will explain them later. Well, here you can see the contour of the Netherlands. And well, when you are familiar with this kind of tools, you recognize these buttons where you can zoom out by clicking on the left, zoom in. Well, you can pan, of course. You can zoom into a specific location, and you can always go back to the full extent of the map you selected. Well, you can calculate the distance between two points. Okay, that's the most important of this window for now. And well, now we started iMOD, and I gave you a small introduction about zoom options and about the file manager, but most important for now, I'll give you the 3 most important file types, because as it comes to grounded modeling and kind of modelings, you often need grid data, you need pointed data, and you need vector data. In an iMOD, these files are called, they're called IDF files, IPF files as it comes to point files, and GEN files for vector. I will show them in iMOD. Well, here you can see it, this topography of the Netherlands. It's typically a vector file. The second file is, we'll run with this button here, and we'll just zoom to the full extent. From the name I can see it's some kind of permeability file, and it is a grid. You can see it's called an IDF file. If you click on the I button, you get some more information about the IDF, about the extent we're looking at now, something about names and location of the file, something about the number of columns and rows, and some information about the values in the grid. Well, as it comes to the values in the grid, it's also nice to have this button here. It's the well, I call it map value button. If you open this one and hover over the grid, you can see in this column the value under your mouse. It's very nice to have a look at all the data. You can select several IDFs together, up to 200 I think. Then we have a third example. It's a point file. We'll draw it with this button and just have the full extent. Well, they are just points, but from the I can see they are observation points. I can tell you the IPF file and the GN file are just ASCII files. You can create them in Excel or any other tool. And the IDF file, it's a binary file. But in the manual you can see how to create them with maybe another type. It's also possible to read files. We can do it here. It's also possible to open Esri raster files. Here you can see it, .asc files. And there are some other formats you can read. Okay, I think that's some short introduction for now. Let's go to the tutorial for create your own groundwater model. But before I will do that, short intermezzo. It's possible now to create your own model. We'll do it in the next 30 minutes, but also possible to import existing mod flows. Let's go to iMOD again, and there is a tool in the toolbox. It's called Import MODFLOW Model. In case you have your own MODFLOW model, just select which type, which configuration, and iMOD will help you to convert it to iMOD. Okay, let's continue, and I give you a small introduction to the model we're going to create. Here you see a cross-section of our case. We're going to create a groundwater model for an island. It's a very easy concept, so we take an island. You can see in the cross-section we have water on all the sides. It's a lake, and the island, well, there's rain, of course, there's forest, there are some buildings, and we have underneath a clay layer, and the subsoil consists of sand. And in our model we'll construct a groundwater model with 3 model layers, a small one on top and 2 layers on the bottom, because in other tutorials we will continue with this 3-layer system. That's about the cross-section, and let's go to the topography of the island. Well, you can see in blue we have some deep water, we have some shallow water, and well, here the island rises up with some hills, and here you can see some elevation options because we need it later on to create our model. Because I presume you are familiar with groundwater models, and you know that you need some parameter files to feed your model. I'll show you most important files. We're going to create a surface level grid. We have to say something about boundary conditions. We have to construct a pumping well. I forgot to mention that, so I return. The case in this groundwater model in this tutorial is there is an island, and the people are going to construct a well, and the question is, where does the water come from? So I hope at the end of the tutorial we can help them to see where the water is coming from. That's why we need a pumping well to create, and of course the model needs information about recharge, permeability and starting heads. These files we are going to create, I'll show it, and these parameters, we choose them as a constant, they're constant values. And to something about how iMOD handles data and at the end creates a groundwater model. Well, first we have some model data. I just discussed it one slide ago. We have all kind of information, model data, And in iMOD, these files, the location of these files, they are combined in the project file. So all the phenomena, in this case in the island, are combined in the project file. And based on the project file, several run files can be created, because you can imagine not one run file is enough. Sometimes you have some time discretizations based on the same model data. Sometimes you need a subdomain to model, but with the same model data, and sometimes you need for checking another scenario. And it's nice to have one project file, and based on that you can create several run files. So first of all, we're going to create our project file. I have to go back because I promised you that these three files we're going to create in iMOD. So I'll show you now. And we start with the server level. So I go to iMOD. I open the iMOD manager. It can be done by this icon also. And the idea in the tutorial is that we create our surface level grid based on contour lines of the island. So we use the topography of the island. We have some information about the levels of the contour lines, and based on that we're going to interpolate to a grid. So first of all, we have to place our topography in iMOD, and that can be done by clicking on the menu View. We're going to add background image, and you remember the image from the PowerPoint presentation, and I can get it from tutorial 4, and there is a PNG file. It's georeferenced, so if I add it and click on apply, then the image will be on the background. Now we have this image, and now I'm going to draw the contours of this island, and I will add the elevation data as you saw in the PowerPoint presentation. So let's start, and you can do it by clicking on the edit menu and then choose for create feature, and here you can see we can create point files, we can create vector files, and we can create grid files. And I'm going to create a grid file based on contour lines, so I choose for polygon and lines. Then this window opens, and here I can draw a vector file. It's called G. Well, let's start. So I click on this pencil, I choose for line, and then I'm going to, well, it's a little bit rough, but I'll explain you later. You can click with the left mouse button and then close it with the right mouse button. Then we have one shape. It's the shape of the outer line of the model, actually of the deep water. So I can rename the shape. I can call it deep water. You can see the name is changed. And by clicking on the I button, I can add some value. I can add the level. So I click on this button. I'm asked if I really want to add data. Yes. And here you can see the information that is in the shape already. And we're going to add a column by clicking on this plus. And I add the column level. And then I can give it a level, and I think in the PowerPoint it was 15 meters. You can see it here. And all the other values I'm going to add also. Go back to iMOD, and here I click. I write 15. Apply. So now I have one contour of the all contour lines. I can do another one. I can draw a line of the bridge. I can first rename it. And now I see I did some mistyping last time because the hill ridge has a value of a level of 15 meters. Okay. And deep water has a level of, I think it's -5. So now I have only 2 contour lines, but in the tutorial you have to do all the contour lines of this island. In this webinar I won't do it, but normally you can save all the files to a gen file. But for now I did some preparations. I will just open a contour line file I created before. So you can see now I have all the contour lines of the island. And if you have a look at the data by clicking on I, you can see all level information is there. And in order to use this vector file to rasterize it to a grid, we have to set the right column to be used for gridding, and it is column level. So now this data is used. I click on apply, and now I'm asked for what extent I want to create a grid file, an IDF file. I say I choose for the GEN extent, I make it a little bit larger, and I choose for a cell size of 10 meters. And the tutorial suggests to pick the PCG method for interpolation. I click on apply, and I'm asked to save the grid somewhere. I will do it here. You can choose any location you like. I click here. Okay, it exists already, but there it is. We created our grid of the elevation of the island. Of course, we can hover over it by clicking on the value button. Just see the values. But there is a nice other option to look at the island if it is correct. We have a 3D tool. Go to Toolbox, click on 3D tool, and then all the information in this 2D window will be converted to a 3D window. There are some elements that are filled in already. Choose for more accuracy and click on apply, and there my island is shown. The colors are green now. It is default, but when I use the colors of my former view, then it's a nice view of the island. I even can change some view settings, and then we have some more vertical detail. Okay, that's just nice to see that it works. We have a surface level. The next step is, we go back to the presentation. We now have a surface level grid. The next step is to make a boundary grid with the boundary conditions. And if you're familiar with MODFLOW, then you know you have active cells and inactive cells, or fixed cells. So we are going to create a boundary file. And of course, we can use the same type of file. We can just make a copy in our file manager, but also in iMOD there's an option to copy files, to handle files. Let's show you. We go to Map, IDF option, and there is the option IDF Calculate. If you open it, then the window Map Operations will appear. And that's a nice option, because for existing files, based on existing files on file A and file B, you can create a new file, C, with some kind of formula. For instance, you can do additions or subtractions of grids, multiplications or division. This one is very easy, because we say this existing file, our level file, we go to make it the same as we copy it to the boundary file. So the new file C is actually the same as A. So I copy this name to the name of C and I will rename it to boundary. And the other things you can skip, but this is important. The extent of the new file should be the same as the existing map A. So when I click on compute, and the new boundary IDF is created, and it's similar with surface level. You can see it by selecting them both, click the view button, and now you can see both values and they are the same. Okay. But as you all know, the boundary values of a MODFLOW model, they are just integer. It's a 1 for an active cell and a -1 for a fixed cell. So let's change the values in this grid. And I do it by choosing in the map menu the IDF edit option. I use it a lot, so it's very helpful. Here you can do a selection on this grid, and let's say I select all cells with a value more than 0.1, because then I know when I ask to get a selection, I have to do it greater than. Then you can see, if I zoom in, all the cells of the island are selected. And after we did a selection, we can calculate on the selection, and we give it the value of an active cell. It is 1. Click on calculate. Then the grid has value 1 on this location. I can show you that by clicking on the map value button. You can see the island itself is 1. And now we have to do this action again, but then for the parts of the lake, of the water level. So we select all cells which do not have value 1, and here you can see all the other cells are selected. I close it here and I give it a value of the fixed heads in MODFLOW, -1. I click on calculate, and then the boundary grid is ready. You can see only 2 values. It's value -1 and value 1. So now we have actually 2 cells ready. There's 2 files ready for the model, and let's see what we need. We also need a pumping well file. A well file. And therefore we have to see the island topography again, because in the middle, on the blue spot, there the well is located. So we are going to create a well by choosing this menu, create feature, and a well is a point file, so we choose IPF, and there we have the option to create an IPF. By clicking on the pencil button, you can just click anywhere you like, where you want to have your well, and we like to have it in the middle. Only one well, so it's easy. I click one time, and with the right mouse button I leave the draw option. Well, we can give it a name by clicking on A. I call this point the well, and I have to add some information about the abstraction rate. So I click on the I button. Do I want to have additional data? Yes. And here we have 3 columns, the XY coordinate, and I'm going to rename the 3rd column because there I want to have the abstraction rate. I call it Q. And in the tutorial they suggest to start with 500 cubic meters a day. I click on apply. It's ready now, almost ready, because I have to save this file, and I call it just well.ipf. The name you can choose yourself. It was already there, so I override it. But now the files are ready. Let's see. We have a surface level grid, we have a boundary grid, we have pumping well, and now we can add all the other data to the, you remember, the project file, this PREA file. So I continue to the next slide. Here it is. The PRG file we're going to create consists of all these parameters for 3 layers, and well, these values we created a minute ago. So I go to the project manager to create this file, and here you see all the MODFLOW related names, all the modules you're familiar with, like anisotropy, starting head, rivers, wells, etc. And now we're going to add all information we need for a model to this project. And let's start with the top elevation, because we created our surface level grid, and we're going to add that one by clicking on the on this button, and here you have the information about the elevation of the top. There's a lot of information here, but most important for you is this box. Here you can tell iMOD for what model you're going to add some data. Well, we start with layer 1, and for layer 1 the top elevation is in the file, and we created that file because we created the surface level file. We open it, and now we add the system, and now we have information about the first layer. If we go to the second layer, we just click again, and we add information of the second layer. And let's see, the top of the second layer is the surface level minus 1 meter. And minus 1 meter we can add over here. And now we can add this system also. I can show you, you can see it here. The top elevation, first layer we use the surface level, the second layer we used surface level minus 1. Well, you can see we have to fill in a lot here. I'm not doing this in the webinar. I did some preparations, but normally you can add all the data the same way as I did, and then you can save the project file. But for now I did some preparations, and I can load the existing one. When I open it, you can see all the information needed for this model. We have some permeability information. We created a well, so it's placed here, and we need recharge. So now actually our PRG file is ready, and on this file we can create a run file. And to do that we choose this option, define your simulation configuration, and as I told you earlier, you're now free to make some run files you like. For instance, you can deactivate some packages just to do some checks. You can change your temporal configuration. For now it's steady state, but normally you can change that. Maybe you need another submodel, you can do it here, but for now we keep it how it is and just create our run file. We click on OK, and we can save the run file just as we like, but it should be in this map, the run files map. You will be automatically directed to that map. Now we save it, and it's successfully written. So now we have a project file with all the information of the model, and we have a file in order to run one of the versions of the model, and therefore I go to Toolbox, Start Model Simulation, and now we can see in this small window the file we just created, our run file, and you can see by this hatched window, it's the window of our model. There are some buttons is a check if all files we refer to are available. Clicking on this I button, you can even do some editing in the run file itself. We are not going into more detail for now. And well, that's I think most important. Here you can see some buttons to change your model dimensions if you like, or change your output variables now, but for now we do it simple. Just go to a results folder and let's create our results. We call the results folder island, and then we can start our simulation. Already the simulation exists because I did some preparation, but I can override it. And now you see iMOD starts MODFLOW, and the calculation was very fast and it's already finished. Well, when I go to the location where all the files are stored, it's in the user map in model. Here iMOD will place all the files created in our run. If you click on it, you can see several files, and most important maybe are the run file. iMOD creates a copy of the run file to this location, and also a copy of MODFLOW executable and a copy of a script. That's very helpful because maybe you want to change something outside iMOD. You can do it here and just run your model again. If you made some mistakes, you can just rerun the model again. Important folder is this folder, because here you can see the complete MODFLOW series of files, and if you like to see some echo of the model run, just open the list file, and this is just the standard MODFLOW echo file with information about files used, cell size, modules needed, used, and at the end, very important, the water balance of this model. And you can see in the part where the flux is shown that is going out of the model, you can see our well abstracting 500 cubic meters a day. So now we saw the results. We can also look at the results in grid form. These are the heads for the 3 layers. So we can open these grids, these IDFs in iMOD, but let me give you a nice other option. Because if you go to map and quick open, you can very fast open different results of our model. So our model is called Island, and let's load all the heads we just calculated. I select them all, click on open, and there you can see all 3 head files are opened. Let's look at the first one. Well, you can see the form of the island, and let's look at it from the 3D option. I give some more accuracy to the view, and here you can see the calculated groundwater head, and you can see nice in the middle of the island. You can see the effect, the image of the well. Okay, that's a nice picture. You can also go to the 2D viewer. You can change, for instance, the legend, because this is a, if you click on the rainbow button, you get to the legend. This is a stretched legend. You can also ask for some classes. I do it very fast, but let's say give me 10 classes. When I click on OK, you can see some more classes. And now we just draw colors for the complete area. You can also select another way of viewing and show the contour lines. I can zoom in a little bit, and here you see the contour lines. You can enlarge the. Okay, this is a nice view. But even now we don't have enough information to see whether the well in the island only abstracts rainwater or also water from the lake. Therefore, we also can do some pathline analysis. And well, I have some minutes left, so let me show you how we can do some pathline analysis in order to see where the water comes from actually. And therefore, I create an iMOD path run file. And if you are familiar with pathline analysis, you know you need some information like the groundwater fluxes on the island, you need the boundary conditions, you need top and bottoms of the layers, and you need some information about the porosity. Okay, I return to iMOD again, and let's start by defining the starting points. Let's start the starting points from sea level, from 0, and then let's see where they end. So I click on Toolbox and I choose Define Start Points. Here I can enter the name of the start point file. I did some preparations, so for now I give it another name. You can choose your names yourself. And here I will open the window to prepare the start locations. All my starting points should be located within the area of the island, so I draw with the polygon the island borders. Oh, this one should a little bit better. Okay. And then I'm going to give some information in this tab on where to place my starting points. They will be placed with a distance of 25 meters in the X and Y direction, and the top level I will give it 0 meters sea level, and the bottom also, so it's just one. I place just one starting point, and let's see where they end up. Well, these are a lot of data points, so maybe I change the distance between the starting points and make it 50, and I redraw again. Okay, now you can see the starting points. Okay. Now I created my starting points, and the next step is to really start the pathline simulation, and therefore I need some additional information. I showed you already you need this kind of information: groundwater fluxes, boundary conditions, etc. For this webinar it's maybe a little bit too much to show you all, but I did some preparations and I can load all the information I just showed you from an IPS file. And if I open it, you can see here boundary settings for all the 3 layers. Here I have top and bottom information, again for all the 3 layers, and the porosity information. The last step I need to do is to say if the calculation should be forward or backward, and after that the iMOD flow file will be flow line file will be created. I did some preparation so I can just load it here. It's in this user file in the model I just ran. It is called Island, and here we have 2 files, and one of them, the IFF file, is the file with the flow path. I just remove the topography, and then you can see actually that this is the well in the middle, and the points starting here, they go to the lake, and the points starting over here are going to the well. So there is no lake water entering the well. You can also show these streamlines in 3D, of course. And then you can see in the middle of the model, there are a lot of lines now, but you can have some information, detailed information about location where the water comes from. So I think that was it for now. It's the end of tutorial 4. Well, thank you for your attention to this tutorial. If you say, well, I want to continue with iMOD and you need some more basics on iMOD, for instance, more on editing or on viewing in 3D or cross-section, then I advise you to do tutorial 1, 2, and 3 for yourself. And if you say, well, I want to need some information about enhanced groundwater flow simulation, I can recommend you to go to tutorial 5 and 6, and it's more about run file configuration, more about simulation with different cell sizes or simulation with different areas of interest. So that's some additional information for you. And if you want to need some more information about iMOD, maybe meet people as it comes to iMOD, then I can advise you to coming iMOD events. The first one is on June 15th. It's a Dutch iMOD user day during the Deltares software days. Information you can find on the website. And for the international guests, I can recommend you the Delft software days, the international Delft software days, and they will be scheduled in November. More information you can find on the Deltares website. Well, again, when you need help after this webinar, I ask you to go to the website and maybe use the online forum to ask your questions and better receive your answers. For now, it's the end of the this live webinar. The next hour maybe we have time for a live chat session. You can ask questions on the use of the Graphical User Interface, iMOD, or maybe some extra options in iMOD. So maybe we can do a lot of chats by the by texting, and if some questions are very important, I can also show them live in my on my computer. So, well, let's have a look to my colleagues of the panel, and I will be silent for a moment, but we will be back.